All right, let's jump right into this explainer. Today, we are cracking open the absolute gold standard for lighting experts, the ANSI/IES RP-30-20 Recommended Practice Standard. And specifically, we're zooming way in on Section 9.0. This section is essentially the master playbook for typical museum lighting solutions. Have you ever stood in a gallery and wondered why a painting just seems to pop off the wall, or why an ancient artifact feels so incredibly dramatic? Well, it's definitely not by accident. It is meticulous, highly technical engineering. Over the next few minutes, we're going to unpack the exact step-by-step lighting solutions that transform a boring dark room into a breathtaking exhibition.
Now, to ground our entire deep dive today, consider this idea from Thomas P. Campbell. He points out that museums are, above all else, places of authenticity. The objects in them are real. So lighting isn't just about making things visible so you don't trip over them in the dark. It's the absolutely critical tool we use to preserve and reveal the raw physical truth of human history. In a world totally saturated with digital copies, lighting is the bridge that connects us to the actual physical reality of the object right in front of us.
Which naturally brings us to the ultimate million-dollar question. How exactly do you light a priceless masterpiece without accidentally ruining it, or washing out the colors, or casting a massive shadow right over the most important detail? Well, we're taking a spatial tour of a museum today to answer exactly that. Oh, and a quick heads up for our journey. Whenever we mention a solution highlighted in vibrant green, pay close attention. That color signifies a definitive, approved industry standard pulled directly from the Section 9.0 guidelines. Basically, green means go.
Okay, let's kick things off at the perimeter walls. Every lighting designer has to calculate the exact physical and spatial geometry between a visitor and a flat painting. The average viewing distance is typically mapped out at exactly 1,830 millimeters, which is about 6 feet. That's literally step one. Designers build their entire lighting plan based on where a human being, whether standing or sitting in a wheelchair, is actually going to be positioned. The goal here is pretty simple but hard to execute. The light has to hit the artwork perfectly from above without bouncing an annoying glare back into the viewer's eyes at that exact distance.
But here's the catch. Uniformly lighting a massive vertical canvas from top to bottom is incredibly difficult. Naturally, the top of a painting is always closer to the ceiling fixtures than the bottom is, right? So here is our very first green light solution. Use what the industry calls wall wash lighting units. Instead of relying on a narrow, intense spotlight, these specific fixtures are engineered to literally wash the wall. They create this broad, perfectly even spread of light across large vertical surfaces, totally ensuring the bottom of a mural is just as crisp and visible as the top.
So it really all comes down to geometry, specifically the 30-degree angle from the vertical, which is our next green highlighted standard. This specific angle is the absolute golden rule in museum lighting. But why exactly 30 degrees? Well, it turns out to be the mathematical sweet spot. It effectively bounces any harsh glare down to the floor completely away from your eyes, while simultaneously pushing any shadows cast by the picture frame down below the actual artwork. It's just a brilliant, elegant piece of calculation.
Building on that exact geometry, if we compare that standard 30-degree angle with a steeper 45-degree angle, you start to see a master illusionist's trick that curators use all the time. Let's say a canvas has really thick, heavy, textured impasto paint. You might actually want to use that steeper 45-degree angle to dramatically highlight that texture through tiny micro-shadows. But on the flip side, if a canvas has unwanted surface flaws or wrinkles, you just use a shallower angle to flatten out the surface and magically hide those irregularities. Light literally dictates the physical texture we perceive.
All right, having mastered the flat perimeter walls, let's step away from them and walk right into the center of our hypothetical gallery. Because the moment we step into the middle of the room to confront three-dimensional artifacts, the rulebook completely changes.
Just look at how the shape, the deep texture, and honestly, the sheer menace of a spiked mask completely transform depending entirely on where the light hits it. With 3D objects, designers get to unleash their entire palette of controllable light. Front lighting kind of flattens the whole thing out. Side lighting catches the sharp edges of the texture, and then a dramatic top lighting creates these deep, eerie shadows in the crevices. The angle of the light literally dictates the emotion you feel.
And hey, this concept applies to everything, whether we're talking about a small, intricate wooden mask or a massive historical military jeep suspended in midair at a history museum. Three-dimensional objects absolutely demand that we consider the broader story being told. The lighting hitting a suspended vehicle isn't just about basic visibility. It's actively creating a sense of action, weight, and historical drama.
So what's the official Section 9.0 standard here? Well, Here is our green certified rule for 3D artifacts. You absolutely must hit them from several different directions to properly reveal their complex form. But just as crucially, and honestly this is a mistake a lot of amateurs make, you must always illuminate the background behind the object. If you don't light that background, the artifact just looks like it's awkwardly floating in this weird black void. Not only does that disconnect it from the physical space, but that harsh contrast will actually cause serious eye strain for your viewers.
You can really see how these two spatial rules perfectly contrast with each other. It proves that the geometry of the light has to fundamentally shift the exact moment an object lifts off the canvas and enters our 3D space. Flat objects, they need that uniform wall wash at a 30-degree angle. 3D objects, they demand multi-directional shaping combined with clear environmental context.
Okay, let's journey even deeper into the museum. We are stepping off the main, open gallery floor and diving into the most highly controlled, specialized microenvironments in any institution, enclosed glass display cases, and those fully immersive dioramas. The definitive, green light solutions here are incredibly strict, mostly because we're placing lights dangerously close to priceless, highly sensitive objects. First off, you must always use a physical protective barrier between the lighting unit and the artifact, no exceptions. And for the internal case lighting, the ultimate sustainable preventative solution is using an LED light source paired directly with fiber optic light guides. This exact combination pipes beautiful, crisp light directly into the case without transferring any of the damaging heat or UV radiation that traditional older bulbs produce.
Now, what about those magical, immersive dioramas that totally transport us to another time or place? Well, the standard mandates concealed or dual lighting systems for these special environments. This is another major green light solution. It basically means using separate, cleverly hidden light sources. One system, specifically tailored to light the primary objects or mannequins, and a completely separate one for the painted backdrop. This guarantees the entire scene looks cohesive and theatrical, all without frying the extremely sensitive materials trapped inside the display. Of course, if you happen to be designing for a zoo or an aquarium, these technical standards have to bend in a totally unique direction. In a dynamic space with living aquatic life, we aren't just lighting inert stone or canvas anymore. Designers have to carefully accommodate natural sleep-wake cycles, the circadian rhythms, and the overall biological well-being of a living, breathing collection. The light has to look absolutely spectacular for the visitor, sure, but it primarily has to be biologically healthy for the animals.
But you know, even with all these strict geometric rules and preservation standards we've talked about, museum lighting is, at its very core, still an art form. Take a space enveloped in completely saturated, dramatic, deeply colored lighting. Sometimes intentionally breaking those standard visibility rules and flooding a room with deep color is exactly what the curator ordered. It's how they convey a specific meaning, create a heavy atmosphere, and ensure the viewer truly feels the art on a visceral level. To completely wrap up our explainer today, here is your ultimate Green Means Go checklist. This perfectly summarizes the best practices from Section 9.0 that we've covered. It's essentially the blueprint for turning a dark room into a world-class exhibition. You have to take a holistic approach. You use a broad, uniform wall wash for vertical surfaces, aiming for that preferred 30-degree angle. You use multi-directional lighting for 3D artifacts to show form while preventing eye strain. And you absolutely rely on LED and fiber optics to keep enclosed display cases completely safe from heat and UV damage.
I want to leave you with this final thought. Museum lighting truly is the invisible art that makes all other art visible. The Section 9.0 standard we just explored, that's essentially the highly technical playbook for creating that invisible magic. So the next time you visit an art gallery, a history exhibit, or even an aquarium, just take a step back for a second. Look up at the ceiling. Notice the angles. What will you really be looking at? The priceless object itself, or the brilliantly engineered light that's revealing it to you? Thanks so much for joining me on this deep dive, and keep your curiosity bright.